So here are the values that I came out with. First, I rounded that $24.99 to the nearby 25, and then I found a 10% discount amount of $2.50. I subtracted that from the 25, and what I did is I thought about it as being 3, and so I subtracted 3 from 25 and got 22, and then I added back in the 50 cents, so I could do that in my head. That's a little trick I use. You can also take that $2.50 times 4, do that on your calculator, or think $2.50 times 2 is going to give you 5, and then double it so you have 4 of them, and that'll give you 10. And then I subtracted 10 from the 25 and got the 15 for the total bill. This 70% one, I decided to show it as 30% on, because 70% off means that there's 30% on. So 30% would be 3 of the $2.50 items, or $2.50 discounts. And then when I multiply those, 250 plus 250 gives me 5, and then another 250 is the 750. And then I looked at the fourth of 25, just like we did for this 20. It's a little bit harder, so you can think about something nearby. If you like 24 is easily divisible by 4, so you might just use 24 and then come up with $6. $6 off would give you $19 for your total here. So a lot of different ways to work these. Your estimates should be in the same ballpark as mine. And I do want to remind you that if you want the exact bill, you would take $24.99 without doing any rounding and multiply by 0.1, and you would get 2.499. And then you would subtract the $2.50 directly from the $24.99. You would get $22.49. And we got $22.50, and we did round up by 1 penny, and so you can see we're just a penny off from the exact figure. So I'm hoping that you do know how to calculate the exact amount of a tip or a discount or a tax by just multiplying the decimal form of the percent by the original, and then add or subtract that amount from the original. And again, here we are talking about percent decreases, because we are decreasing a value by some percent of its value. So we often talk about percent increase and decrease from a different perspective, not I'm finding the amount of tax on my bill and then finding my total bill, but we talk about it as the tax being either a percent increase on the bill, or in the case of the discount, it's a percent decrease on the bill. So we look at those two from a slightly different perspective, and when we do that, we talk about the absolute change, and that is, we talk about that as the absolute value of the difference between the old and the new amounts. So you can show that as those straight up bars mean absolute value. So if you come up with a negative number, they just drop the negative. If you come up with a positive number, we just keep the positive. We're talking about the exact distance between two numbers, and we don't care if you had to go to the left or to the right to get there. And what that lets us do mathematically is show an expression like new minus old, and we don't have to care if the new value is bigger or if the old value is bigger. We'll get the same actual distance between those two values because we just drop any negatives that we come up with. And that's absolute value. So that's the absolute change. It's the exact distance between the starting and the finishing, the old and the new values, with no regard to the sign. Then if we want to do the percent change, that one is, we have a formula, and that's going to be the absolute change divided by the old, and to that we will just multiply by 100 to convert it into a percent, because you'll get a decimal when you do that. So in terms of these percent increase and decrease problems that we've already done, the old would be, in this case, the original value of the item, and the new would be the sale price of the item, and then the amount of the discount is going to be the absolute change, and we would end up with 10% if we plugged it all into this percent change. Same kind of scenario, we're just looking at it slightly differently. If you know the original price and the sale price, you can plug them into this formula and find out what was the percent of the discount. So that's kind of neat.